Hey everyone, and welcome to lesson 5.1, which is on inequalities with a variable. In this lesson, we will be talking about comparing variables to numbers using inequalities. Before we get into all of that, what we need to understand is that an inequality means that the two sides that we are comparing are not equal, and that's a vast difference from what we've talked about in chapter 4 when things were equal to each other. Now, when we are comparing the two sides of a math statement, there are four ways that we can compare it. The first way is by calling something less than. We show that by using an arrow pointing to the left. The second way is calling something greater than, and we display that by using a symbol of an arrow pointing to the right. And those two are our first two basic symbols, just saying one thing is less than another, one thing is greater than another. Moving on to our third type of inequality, we have what's called less than and equal to, and that is shown with the symbol of less than, and then below it a line drawn underneath the less than symbol. That line underneath the less than symbol is basically half of an equal sign, since we're kind of combining two terminologies. We're saying something is less than, but it's also equal to at the same time, just adding an additional layer there, and that is why we have that combination of less than with a half of an equal sign below it. The last type of inequality that we have is called greater than or equal to, and that one uses the greater than symbol along with half of the equal sign again, kind of as a combination. All right, now that we've talked about the four different types of inequality symbols, let's just go ahead and get into some examples. And these examples will help us display how to look at inequalities and explain inequalities and graph them on a number line. Okay, so the first one that we have is the graph of x is greater than 5. And again, just as a quick reminder, that symbol in the middle there is greater than. I'll write that out. So, since we have x is greater than 5, all we have to do first is locate 5 on the number line. And we'll just count up from 0, 3, 4, 5. And now we know where 5 is on the number line. To display greater than or less than, we are going to use a circle. And the reason that we use a circle anytime we have greater than or less than is because numbers that are greater than 5 are going to be 6, 7, 8, 9, 10, but not 5 itself. So since we are not including the number 5, we're just going to draw a circle around it. It's almost like a barrier saying, hey, we're not including 5. And then we color and shade everything that's going to be larger than 5 to the right. Now, here's one thing that I will show you. Notice that in my shading, I shaded everything to the right and I drew the arrow, right? That arrow shows me and points to all the numbers in the number line that are going to continue being greater than 5. In inequalities, we have tons of different answers, multiple answers, right? What's a number greater than 5? 6, 7, 8, 9, 10. All of those work. And notice that when I shade, that arrow is pointing to the right, right? And I shaded to the right of the open circle that I made. Well, look here. In the problem, our greater than sign is also pointing to the right. So they match. And that's a good little trick to understand like which way do you shade if you ever get confused on that. If the arrow is pointing to the right, then we shade to the right. If the arrow is pointing to the left, we shade to the left. They always match. All right, so if we can understand that, let's look at a little bit of a wrinkle into our inequalities. In problem number 2, we have same thing. We're trying to graph, and we're trying to graph -3 is greater than or equal to y. Well, the problem here is that if we look back in number 1, and I'm going to highlight this in blue, notice that x is on the left of the equation, or of the inequality in number 1, but now in number 2, the variable is on the right-hand side. Now, typically, we normally see inequalities and see those expressed, how they're expressed in problem number 1, right, with the variable being on the left-hand side. Should you ever get a problem where the variable is on the right-hand side, we can fix that. And I would recommend that everybody fix it and help yourself out, because it helps you graph things and makes things more straightforward. So all we have to do is take that whole equation and flip it around, right? Make a mirror image of it, right? So we say y is less than or equal to -3. Now, why did I write less than? Why did I change the sign? The reason I changed the sign when I flipped everything around, almost like flipping a pancake over in a pan, right? It's when I flip it over, I have to make sure that the inequality sign keeps pointing at the same thing. So if we look at the original equation, and I'll underline this in red for you guys so you can see it, right? Right here, the inequality sign was pointing towards the y, and now when I flipped everything around, the inequality sign still is pointing towards the y. That helps us to see that we've set the problem up right, and now that we have the problem set up the right way, where we have y is less than -3, all I have to do is find my number. So if I were counting down -1, -2, -3, and put my circle around -3. But let's notice that the inequality isn't just less than, it's less than or equal to. Since we have less than or equal to, all we have to do is color in that dot, because since it's equal to, yes, we want all the numbers that are less than -3, but we also want to include -3. And inclusion means we get to fill in the dot to show that it's included. And then we do just like the last problem. We shade to the left, since the arrow is pointing to the left now, and we've officially graphed our problem. So just as a quick recap, I'm going to write in the top right-hand corner here just a little thing that we have. Remember, if we see less than or greater than, we are going to use an open circle. If we see less than or equal to, greater than or equal to, we are going to fill in that circle and use a closed circle. And that's just a good rule of thumb to have whenever you are graphing inequalities on a number line. This will also come back in different other parts of math, but just know that less than, greater than is always associated with open circles. Less than, equal to, greater than, equal to is always associated with closed circles. All right, so moving on to the last little bit of our equation here, our problems here, we have number 3, state the inequality. Well, the first thing that I notice, and I'll highlight this in blue, is that I have an open circle at -2. So that means I'm either going to use less than or greater than. I need to go ahead and write my equation. So I'm going to have x that I'm comparing, and I'm going to have -2 that I'm comparing because I have the open circle at -2. Now I see that I'm shading to the left. So since I have an open circle and I'm shading to the left, that gives me less than. Right? It's less than because it's shading to the left. It's not less than or equal to because we have an open circle. All right, moving on to our last example here, which is number 4. We have a closed dot at 1, so that means that I am comparing a variable to the number 1. The closed dot means that it's going to be something or equal to, and I'm shading to the right, so that means my arrow is going to point to the right, and that gives me the inequality of x is greater than or equal to -1. Okay, guys, so that's been a very quick and short review of how to handle inequalities, how to graph inequalities, and how to take a graph of an inequality and write that statement from it. hopefully this has helped refresh you on this information or help teach you some of this information. It's just very kind of a quick review. This should set you up to solve all the problems in 5.1, but if it doesn't, as always, if you have any questions on this or need any clarifications on anything, please let me know.